All right, here we go. Starting unit number 3. Hopefully your test went okay and there weren't any big issues. So unit 3 is inequalities and rationals, and we are going to start out by solving some linear inequalities. Learning goals straight up, solve linear inequalities. And by linear, we just mean the degree on x is 1. We're not going to be doing any polynomials or quadratics or anything with a degree higher than 1. So to start out, we'll start talking about, well, what is an inequality? And we've already dealt with these. We talked about them when we talked about intervals of increase and decrease of graphs. We talked about them when we did absolute values. So we're just going to pick up from that. So an inequality is any expression that does not have an equal sign but instead has one or could be more, so one or more of these guys below. And we could have a less than symbol. We could have less than or equal to. We could have greater than, and we could have greater than or equal to. So it's an equation if it has an equal sign. That's a statement of equivalence. Left side equals right side. For an inequality, it doesn't mean they're equal. It means they could be equal, but they're either one side is less than the other side, one side's greater than the other side, or it could be less than or equal. So it could be equal, but it also could be a less than. So these typically don't have, I mean, you're not going to have a single answer, like a unique value of x that makes the left side equal to right side. Instead, you're going to end up with a range of solutions or an interval of solutions. Let's get to some examples. So we got our first 3 examples. And how you solve these, you kind of just treat that inequality, you treat that less than symbol like it was an equal sign. So generally speaking, you want to have all your variables on one side and all your numbers on the other side. So let's take this -1 and move it across, and just like we would normally, when we cross that, we're going to change the signs and become +1. So we're going to be left with 3x is less than 8 plus 1 is 9. Same steps. Divide both sides by 3. X is less than 3. So this provides us with a solution set or a solution interval. Now you can write all of these one of 2 ways. You can write it with a less than or greater than sign with the inequality sign, or you can write it with brackets. So less than 3 would be 3, anything less than 3, but since this wasn't equal to, it can't equal 3. In other words, this can be anything less than 3, so from -infinity to 3. From -infinity to 3. And don't forget, circular brackets does not include the point, and square brackets does include the point. You can never have a square bracket on an infinity sign, and since this is not less than or equal to, we also have a circular bracket on 3 and not a square bracket. Before moving on to B and C, I just want to give you a visual. Now, normally we play around with some graphing software. We can have some fun with this unit and do some more experiential learning. However, given that we're virtual, I'm just going to give you some screenshots and try to talk over them as best I can. So if you take a look at that, A was 3x minus 1 is less than 8. My red line is my 3x minus 1. My blue line is my y equals 8. And what this is asking you is, when is the red line less than the blue line? When is my red function lower than my blue function? Now that green shaded area is when I enter that inequality into the graphing software, it spits back all of the solutions to me. And it's dashed because it doesn't include it. If you look at your x-axis, it's going up by ones, 1, 2, 3. So everything from 3 and to the left, to negative infinity. Well, you can clearly see that the red and the blue intersect when x is 3, and anything to the left, the red one is lower than the blue line. And that's why that's a solution set, because we want to know when is it less. If this was a greater than question, when is my red function above my blue function? Well, anything bigger than 3 to the right. So that just gives you a visual of kind of what we just did algebraically. Moving on with B and C. Same idea. Bring that over. Becomes plus 6. 2x is greater than 6. Divide both sides by 2. X is greater than 3. C. Same idea. Bring this over. That's going to become plus 27. Negative 3x is greater than or equal to positive 27. Divide both sides by negative 3. Now here's where you have to kind of take note and pay attention. We did this during the absolute value note. I mentioned it. Whenever you divide by a negative, the inequality flips. I'm just going to put that reminder there. When you divide by a negative, the inequality flips. Only when you divide by negative or multiply by negative. So we're still going to have x on the left, and 27 divided by negative 3 is negative 9, but the inequality is going to flip. So instead of it being greater than or equal to, it's going to be less than or equal to. So yeah, make sure you don't forget that important point. Example number 2, solve. So we're slowly going to get more and more challenging, more and more involved. So bring the 35 over, becomes negative. We have negative 2x greater than or equal to 20 minus 35, negative 2x, that's negative 15. Divide both sides by negative 2. Don't forget, what did we just talk about? Flip the inequality when you divide by a negative. 15 over 2, or 7.5. B. A couple different ways you could do this. You could distribute, collect like terms, move stuff around, or since we're multiplying, I'm just going to change it up. We could get rid of that 14 right off the bat. I'm multiplying by 14. Let's divide everything by 14. Those are gone. 2x minus 3 less than or equal to 42 divided by 14 is 3. Bring that negative 3 over, becomes positive 3. 3 plus 3 is 6. Divide both sides by 2. X is less than or equal to 3. If you chose to distribute, you get the exact same answers. C. We can't just straight up divide. We got things going on both sides of the inequality. We really have no choice but to distribute. So we're going to distribute. Negative 5x plus 15 greater than or equal to 2x plus 10. Just to keep everything positive. Actually, no. We'll stick with, we won't be confusing. We'll stick with my letters on the left. But keep in mind that if you don't like this, if you're someone that kind of was like I was about to say, move the -5 so it's positive to stick with the 2, you can do it that way as well. So we're going to bring the 2 over. X, it becomes -5x minus 2x. And then 10, bring that 15 over, becomes minus 15. -7x greater than or equal to -5. Divide both sides by -7. U divided by negative, inequality flips. 2 negatives make a positive. So x is less than or equal to 5/7. If you put your letters on the right, the inequality would be flipped, but then you'd have your x on the right and the statement still basically reads true. Example number 3. Now these are actually called double inequalities. Before we get to solving these, so these are called double inequalities. And we've already dealt with these. You kind of use these a little bit for domain and range. And your goal of this is you want to get x isolated in the middle. So we want x in the middle isolated. That's your end goal. So how could I get x by itself? Well, forget about what's going on the left and right on the outer extremes. Let's just look at the middle. How would you isolate x? Forget about 22, forget about 54. If I wanted to get x by itself, the first thing I would do is, well, I would try to move 8. But we got two things going on, two inequalities. We can't move 8. And remember, when we solve that way, we're never truly moving something. It's kind of like that, but really what you're doing is the opposite operation. And what's the opposite of subtracting 8? Well, adding 8. So what we're going to do is we're going to do plus 8, plus 8, plus 8. 22 plus 8 is 30, is less than. Negative 8 plus 8, 0, it's gone. And then 54 plus 8, 62. Then, to get x by itself, divide everything by 2. 15 is less than x, is less than 62 divided by 2, 31. Same idea for b. This one's a little bit trickier though, because if I was to add 5 to everything, which we might eventually have to do, it still doesn't give me all the x's in the middle. We can't move things, not with double inequalities. You want to do opposite operations. So let's start by adding 5 to everything. Maybe that was our gut feeling. So we want to get x by itself in the middle, plus 5, plus 5, plus 5. That gives me x minus 24. Negative 5 plus 5, that's convenient, that's gone, good. And then 12 plus 5, 17. So we have x plus 17. But now I got x's in on the extreme left and right, and I don't want them there, I want them in the middle. And we know we can't move them. So again, same idea, opposite operations. What if we subtracted x from everything? Well, x minus x, that's gone, you're left with negative 24. 4x minus x is 3x, and x minus x is gone, you're left with 17. Divide everything by 3. Negative 8 is less than or equal to x is less than or equal to 17 over 3. Now I've been writing these with inequalities just to change it up. I'm going to show you just, again, if you're someone that prefers doing it this way, you could write this as from negative 8 to 17 over 3. And since it's less than or equal to, the key there is equal to, we use square brackets. That's another way you can write your solution. It's really up to you. Now, excuse the white writing. I was going to pop up some pictures for you. So what I have there for you is the graph to A. So 22 is less than 2x minus 8 is less than 54. And the red line is my 2x minus 8. The blue line is my 22. And my green line is 54. Excuse me. And what I want to know is, when is 2x minus 8 between 22 and 54? That's what I want to know. So if I take a look at that, when is my red line between the blue line and the green line? Well, I've highlighted those points for you. Between 15 and 31. And that's what we got. 15 is less than x is less than 31. Visually, that's what we just did algebraically. And where it's kind of double shaded, it's a little bit gray looking. That's our solution set. And again, hopefully providing these pictures just give you another visualization of what we're trying to do. C. So let's start on the inside again and work our way out. And we're going to have to distribute on the inside. So if I distribute that 3, 6x plus 12 minus 2x minus 2 less than or equal to 46, collect like terms. 6x minus 2x is 4x, 12 minus 2 is 10. Subtract 10 from everything. I'm going to skip writing that step. Oh, actually, no, never mind, I'll write it just in case. 20 is less than 4x is less than or equal to 36. Divide everything by 4. 5 less than or equal to x less than or equal to 9. Or you could write it 5, 9, square brackets, since it's less than or equal to. Hopefully it's not too bad now. We kind of get the idea of what we're doing. And this is slowly building our skills towards getting to a little bit more difficult solutions in future lessons. Our fourth and I believe final example. Just going to ask things a little bit differently. Given this inequality, is x equals 1 a part of the solution set? And then we're going to solve the inequality. So to ask if it's a part of the solution set means that if it was, it would be true, it would be a true statement. The left side would be less than the right side. So all we have to do is just sub in 1 for x and see what happens. So 1 plus 4 over 3 and 1 minus 2 over 6, and 1 plus 4 is 5, 5 over 3, and 1 minus 2 is negative 1 over 6. Now fractions might not be your thing, but hopefully, so right now we have 5/3 is less than negative 1/6. Hopefully common sense would dictate that a positive number is not less than a negative number, regardless of your comfort level with fractions. So 5/3 is not less than negative 1/6. So what does that inconsistency tell us? It tells us that no, x equals 1 is not a part of the solution set. So therefore, x equals 1 is not a part of the solutions or solution set. Solve it. One way to solve this is to cross multiply. I mean, you could do that. you're going to be working with higher numbers. Another way to solve this is just to clear the fractions. And if you remember from clearing the fractions from grade 10 or 11, it's like multiplying by the lowest common multiple, which in this case between 3 and 6 is 6. So if I multiply that by 6, my 6's beautifully cancel because 6 divided by 6 is 1. And if I times this by 6, 3 goes into 6 twice. 6 divided by 3 is 2. So what we're left with is 2. X plus 4 is less than x minus 2. Distribute. 2x plus 8 is less than x minus 2. Bring that 8 over, becomes negative. Bring this x over, becomes negative. 2x minus x is just x. Negative 2 minus 8, negative 10. Again, just for variety, less than negative 10 would be from negative infinity to negative 10. Circular brackets because it did not include those points. There is some C work, and that is the end of your lesson because Stone Cold said so.